Hello everyone, this is Mrs. G. We're going to cover Module 6, which is dealing with inequalities. Most of this video lecture will cover most of your Delta Math problems. There's one that has to do with graphing an inequality that I will cover in another lecture. So first of all, what is an inequality? Well, an inequality is going to have a greater than, a less than, a greater than or equal to, or less than or equal to sign in the equation. And I've written an example down here with a -8 is greater than 2x plus 6. So that makes it an inequality. And there's several things that you're going to be doing with this type of a math problem. So let's look at the first part. The first part is going to be determining whether an integer satisfies this inequality, whether or not it makes it a true statement or not. And we're going to be inputting integers where those variables exist in that inequality. An integer is a number like a -3, -2, -1, up to a +2. It does not have any fractions in it. So in these particular problems, what we're trying to do is we're trying to plug those integers into the inequality to see whether or not the statement is true, which if it is true, it's going to be considered a solution. If we plug those integers into the inequality and it's not true, it's considered a false statement, so it's not a solution. In these particular delta math problems, they're going to give you probably three integers to put into the inequality, and all of them could be a solution. None of them could be a solution. One could be a solution, or multiple of them can be a solution. So you're going to have to plug each each integer into the inequality, determine whether or not it was true or false. So whether or not it's a solution or not a solution. So we're going to look at this first one. -5 is greater than 6x plus 9. And in Delta Math, they're going to give you three options. And so they're asking me to input 6 where the x is, 4, and a 0. So take a look at the answers as equaling x equals 6, x equals 4, or x equals 0. And what I did for each of these math examples is where the x was, I put the 6 in. So let's take a look at my first solution. I put a -5 is greater than 6 times 6 plus 9. And I did the math here, 36 plus 9, this made it a 45. So right now I have -5 is greater than -45, which is not true. That's not a solution. So I can say that this is not going to make the statement true. Now I'm going to slide it over and show you what it looks like to put a 4 where the x is. So I put 6 times 4 plus 9. I did the math on that to get a -5 is greater than a 33, which is not true. -5 is not greater than 33, so that is also not a solution. My third option is say x equals 0, so I'm going to put a 0 where the x is in there, and it looks like this solution right here. -5 is greater than 6 times 0 plus 9. Ultimately, that has -5 is greater than 9, which is false. So that is not a solution. So as I said, you can have as an answer that none of them make a solution, which is what this example is showing. All right, so that is plugging integers into the inequality to find if it's a true or false statement. I think that's pretty clear what you need to do. So let's move on. Next thing that we're going to do is we are going to look at the linear inequality and number. All right, and there's going to be a level 1 and level 2. And really what they want you to do is to graph this information on a number line, right? So number line that looks like this, -2 or so, right? And you're going to put the solution and express it on a number line. The one thing that we need to be aware of is when the I want to call it an equation, when the problem has a greater than or less than symbol, we're going to use an open circle on the number line, means that is not part of the solution. If it's a greater than equal or less than or equal to, we're going to use a closed dot. So very simple and straightforward these are. Let's take a look at the problem. I'm going to start this one fresh. So for this number line 1, I have 8x minus 9 is greater than negative 17. So I'm going to add 9 to both sides, and I get 8x is greater than a negative 8. And I'm going to divide both sides by 8, and I'll get x is greater than a negative 1. All right, now I need to be able to graph that on a number line. Whoops, sorry. So I'm just going to draw a brief, quick little number line here. And so because that is a greater than, I'm going to put an open circle where the negative 1 is. And it says it wants all values to be greater than a negative 1. So I'm going to draw my line going in this direction, right? We want everything that's going to be greater. Let's take a look at another one here. Let's take a look at this one. This one is looking at, as an example, a negative 6x plus 2 is greater than 32. So I'm going to do exactly what I did, is isolate those variables. So I'm going to minus 2 on both sides to get a negative 6x is greater than 30. Now, one thing I have not talked about is when you divide or multiply by a negative number, all right, and it's only when you're dividing or multiplying by a negative number, the signs switch. You need to reverse the sign. I'm going to call reverse the symbol. So in this particular one, in order for me to isolate the x, I'm going to have to divide by negative 6 to both sides. Because I divided by a negative number, I need to reverse the sign. So this is going to flip. So this would become x is less than a negative 5. All right, so try to remember. That's very easy to not remember that. And I'm just going to draw it on a number line. And I have to start at a negative 5, and it's a less than sign. So it's not a less than or equal to, so it's an open circle. And it wants all x values that are below less than a negative 5. So I'm going to draw it into that direction. So as I said, if you multiply or divide by a negative number, you're going to flip that sign. And, why do we? What is the point of that? Why do we have to flip it? So let's look at an example of why you would have to flip it. Let's say I have a value that's 1 is less than 2, right? That's true. So now I'm going to multiply both sides by a negative 1. So it becomes a negative 1 is less than a negative 2. Remember, I multiplied by a negative number. I didn't change the sign, but I did that in this inequality setup. And as you can see that this is false. So what we would have to do is negative 1, we'd have to have had flipped that sign to make it true. Because when you multiply by a negative number or divide by a negative number, it's going to change which side is larger. And this is why you need to flip it. Okay? Let's take a look at one more problem here that kind of goes into this category. 45 minus 7x is less than or equal to 17. So again, I'm going to isolate that variable. I'm going to minus 45 on both sides becomes a negative 7x is less than or equal to a negative 28. For me to get the x by himself, I'm going to have to divide both sides by a negative 7. Ooh, I did a negative. I need to reverse the sign. Remember that, so it now becomes this. So this becomes a pot of positive x over here, and a negative 28 divided by negative 7 is a positive 4. So now I'm going to draw that on a number line because that's what this, if I could count, that would be good. So hopefully you're not looking at how bad my drawing of a number line is, but I'm going to put a dark circle there where 4 is because it means it's included as a solution. And I want all values x to be larger, so I'm going to draw my arrow in that direction. Okay, so that's how you do those. All right, let's take a look at doing linear inequalities level 1 and level 2. So this would be linear inequalities. It correlates to your delta math, level 1 and level 2. On this one, you're going to have variables on both sides. So negative 7r minus 4 is greater than or equal to 4r plus 2. Again, we want to solve for r. So one of the ways that you could do this is to add 4 to both sides. So it becomes a negative 7r is greater than or equal to 4r plus 6. I'm going to minus 4 off on both sides, becomes a negative 11r is greater than or equal to 6. All right, now to isolate this r, I need to divide both sides by negative 11. Don't forget I had to reverse the sign because of it. So this becomes less than or equal to r, a negative 6/11. And that is the answer to that solution. But there's also another way that I could have solved this. So let me go back up. In math, there's always more than one way of doing something, so it just depends on how your brain works. So I'm going to subtract 2 from both sides, so this becomes a negative 7r minus 6 is greater than or equal to 4r. Now I'm going to do is I'm going to add 7r to both sides, where it becomes a negative 6 is greater than or equal to 11r. To isolate that, I'm going to divide both sides by 11, so negative 6/11 is greater than or equal to r. So in this particular one, I did not have to flip the sign. All right, this is saying the same thing, negative 6/11 greater than or equal to r. Sometimes, not seeing that written in the same way might not look the same, but they have the same solution. So this one I did not, based on how I started, I did not need to flip the sign. This one I had to divide it by a negative 11, and that's why I needed to flip it. So interesting on which way I started, whether or not I had to reverse the sign. All right, let's take a look at another level 1. And I'm only going to solve it one way. I'm not going to do it both ways. So whether or not we solve it the exact same way, that's up to you. 8p plus 10 is greater than a negative 5p minus 1. So it might be good to stop the video now, you solve it, see whether or not we agree, and then move on from that. When you watch someone solve, it's not the same thing as solving yourself. So you can stop it now. I'll just pause for a few seconds and then I will continue, but I hope that you will have solved this on your own and then checking the answer to what I got. All right, so I'm going to add a 5p to both sides. So this becomes 13p plus 10 is greater than a negative 1. Still working on trying to isolate those p's. I'm going to add a negative 10 to both sides. So 13p is greater than a negative 11. I have to divide both sides by 13, so p is greater than a negative 11/13, and that is my answer. I did not need to reverse the sign. Happy, happy, happy camper. Okay? So what does a level 2 example look like? So let me write this out. Negative 9 minus 5 times 10g minus 3 is less than or equal to 3g minus 6 plus 8. Boy, we could just keep going on and on and on and on. Geez, I just did chemistry solving it. This looks like almost like log to me, but it's a 10 times g minus 3. Okay? For some reason, a lot of these have g's as variables in this section. So the thing on level 2 is there'll be distributive property, which you're going to have to do first before you can solve it. So let me do that. So a negative 9, and then I'm going to take a negative 5 times a 10g, negative 50g, and then a negative 5 times a negative 3 is a plus 15. And then it's less than or equal to, and I'm actually going to take the time to combine those two. Why not? If I'm doing some extra work in here, I might as well. So negative 6 plus 8 got that to 2. The less numbers you have to look at, the easier it is to solve. So when you can combine like terms so you have less to view, it's always a good thing. So I'm going to combine these two integers here to give me a positive 6 minus 50g is less than or equal to 3g plus 2. You should easily be able to continue on here to get the answer, but let's focus on continuing. I'm going to minus 3g on both sides, so this becomes a negative 53g and a positive 2 on this other side. I'm going to minus 6 on both sides. It becomes a negative 53 is less than or equal to a negative 4. Okay, now we want to isolate that g. Guess what? We're going to have to divide it by a negative 53 on both sides. And what does that mean? We have to be careful. We have to reverse that sign. So get in a habit, whatever that looks like, so that you remember to reverse it, Negative 53 divided by negative 53 is just a positive g here. Is greater than or equal to, and two negatives divided is a positive, so negative 4 over negative 53 is a 453. What a peculiar fraction, but that's what it is. Okay? So let's do another one. Remember in this one, we did the distributive property first, and what we try to do the whole way down here is to combine like terms so that we could isolate the variable. And we just have to keep track if that is needed to be done with the reversing of the sign. All right, let's look at another example. And again, you may want to stop the video so you can do this on your own and then check to see whether or not we agree. It's always good to agree, isn't it? All right, so we have a negative 7 minus 5 times 3g plus 8 is less than 10g minus 7 plus g. You're going to do the distributive property first, combine those terms together, make less numbers you're viewing. If you have to reverse the sign, don't forget to do that. All right, so pause it. I'm going to wait a few seconds before I continue. And then hopefully you and I will agree on your information on how you solved it. All right, so I'm going to go on and say negative 7. I'm going to take a negative 5 times a positive 3g is a negative 15g. Negative 5 times an 8 is a negative 40. And then I'm actually going to take the time to combine these on this other side to get 11g minus 7. Why not, right? So what I'm going to do now, I'm going to combine what I can over here. That's a negative 47 becomes 11g minus 7. Okay. All right, so let me minus a negative 11g out here and add it to that side, so that becomes a negative 26g. Boy, there's a lot of negatives flying in here. Okay. Now what I'm going to do is I am going to, oh, I dropped a 7 there. A 7, my lucky 7 number here. All right, so now what I'm going to do is I'm going to add 47 to both sides. So negative 26g is less than or equal to 40, positive 40. Hey, there's a positive number in there. Woo, at the very end here. All right, so I'm going to divide both sides by negative 26. Woo, I'm doing that. I better reverse the sign. So automatically I'm going to do that so I don't forget. So this becomes a positive g, and this is a negative 40 over 26, or 40 over negative 26, however you want to say that. I can divide 2 into each of these to make it a negative 20 over 13. So that is my answer to that problem. Okay. We have one more set of inequality problems to do, and then that's what I'm going to call time on this lecture. And you'll be able to do all the delta math except for the last one. But of course, we're saving the best for last. And what we're going to be doing on this one, we're going to do linear inequalities with your most favorite topic, with fractions. Yay, I hear everybody saying, okay? So the methods of doing it, there's two ways of doing it. One of it, you deal with the fractions. You have to deal with them. And the other one is using an LCD method, the lowest common denominator. I like using this method, but I think your Delta Math likes you to use that. So let's just kind of review a little bit about fractions. So if I had to do like 2 minus 2/3, I have to get them in the same denominator. So 2 becomes 6 over 3 minus 2/3 becomes 4/3, right? 6 divided by 3 is a 2. So they have to have the same denominator in order to subtract them. If I had a 1 minus 4/5 and I wanted to do that fraction, I need to change that 1 into 5 over 5 because that shares the same denominator, and that still means 1, minus 4/5, and that equals 1/5. Okay? Kind of a quick review over the little fractions, but this one over here, you're going to have to deal with it. So let's take a look at the problem, and we'll solve this problem both ways. So we have a negative 2 times a negative 4/5 x plus 3 minus x is less than or equal to 3x. It looks kind of similar to the problems that we were doing where you have to do the distributive property first, and that's the first thing I'm going to do. I'm going to multiply that by each of those. So this becomes a negative 8/5 x minus 6 minus x less than or equal to 3x. So what I want to be doing now is I want to combine those x's on the left side, right? So uh, I have a positive 8/5. Sorry, folks. I have a positive 8/5. Uh, Let me just check my math. Minus 6. Okay, positive 8/5 minus 6x minus x. So I'm going to combine these together. So I have an 8/5 x. This is a 1, right? There's a 1 in front of this x. So to be able to do that, it's 5 over 5x, right? Just like I was saying up over here, to give a value of 3/5 x. So combining this side, it becomes 3/5 x minus 6 is less than or equal to 3x. All right, so now I'm going to bring the 3 over on this side, but to do that, I'm going to have to put 3x into a fraction, right, that has a 5 in that. So I'm going to times it by 5 over 5 because that's our common denominator here, and so this becomes 15x over 5. 15x over 5 means 3x. It's the same information, but I had to do it so that I could combine them. 3/5 x minus 15x over 5x. I'm sorry, minus 15x over 5. All right, minus 6 is less than or equal to 0. Don't let that 0 bother you right now. So let me combine these fractions because I can, because they have the same denominator. Negative 12x over 5 minus 6 is less than or equal to 0. I'm going to put the 6 on the other side, right? So I'm going to add a 6 to both sides, so this becomes 6. So for me to isolate that x, I'm going to have to multiply it by its reciprocal to be able to get that to just an x, right? I'm trying to eliminate this fraction. So if I do the reciprocal of that fraction, the 5's will cancel out, the 12's will cancel out. But if I don't make this a negative, I'll still be having a negative x. So I need to do the reciprocal and make sure it's negative. So when I cancel all of those out, I will just have x left over here. So I'm multiplying it by a negative 5 over 12. That means I need to do the same thing over here. And once I do that, sorry, I need to flip the sign because that is a negative number. So this becomes a negative 30 over 12, which is the same thing as a negative 5 halves. That's a mouthful. To be able to do all that and get your fractions straight without getting that all, goofed up. All right, let me do the LCD method here because I like the LCD method better than this, but that's just me. All right, so let's do the same thing. Negative 2 times a negative 4/5 x plus 3 minus x less than or equal to 3x. I'm going to do the same thing. So the starting part is still the same. This is going to be 8/5 x minus 6 minus x is less than or equal to 3x. So that part, doing the distributive property, has not changed. What I'm trying to do is eliminate this fraction. And so what I'm going to do is I'm going to I'm going to multiply everything by 5 over 1. And what I do to this side, I also need to do to this side because I'm multiplying everything by 5. And by doing that, I'm going to be able to eliminate that 5 in this fraction. So when I do this, this becomes, this is going to become 8x. But if you don't see that and you multiply it through, you'd get 40 over 5 x, which would be reduced to 8x. All right, so if you need to multiply that out, you can do that extra step to get 40 over 5x as to an 8x. This becomes a minus 30. This becomes a minus 5x as I'm multiplying that 5 all the way through. This becomes 15x on this side. Once I get that like that, it's so much easier to combine the information. So you can see that this side is 3x minus 30 is less than or equal to 15x. I'm going to add a negative 3x to both sides so I can get it a negative 30 is less than or equal to 12x. Divide both sides by 12 to isolate that x, and that becomes negative 30 twelfths, which 6 goes into each of that to become a negative 5 halves. I didn't have to find any common values like I did in this one in order to minus things. I didn't have to do reciprocals of all that. But you decide which method you like the best and use that. But that is the linear inequalities with fractions. All right, everyone, I will do part 2, which is going to be graphing linear equations. Take care, everybody. If you have any questions, just let me know.